9.6 definite integrals. In 9.5, we figured out how to determine indefinite integrals. Indefinite integrals are really similar to antiderivatives. Definite integrals are different from indefinite integrals because they have endpoints. For example, an indefinite integral might be the integral of f of x dx. The definite integral would be the integral from a to b of f of x dx. That means the area under the curve from x equals a to x equals b. To help us determine the values of definite integrals, we need the second part of the fundamental theorem of calculus, which says that given any definite integral from a to b of f of x dx, that's going to equal to big F of b minus big F of a, where big F is the antiderivative of f of x. For example, let's say that f of x is equal to x cubed. Then the antiderivative of big F of x is going to equal to 1/4 x to the 4th power. So f of b would be 1/4 of b to the 4th power, and f of a, big F of a, would be 1/4 of a to the 4th power. Those are the antiderivatives evaluated at a and b. Well, the indefinite integral of x cubed would be 1/4 x to the 4th plus c. The definite integral from a to b of x cubed dx would be 1/4 b to the 4th minus 1/4 a to the 4th. Why? Because 1/4 b to the 4th, that's just f of b. That's just f of b. And 1/4 a to the 4th, that's just f of a. And by f, I mean big F of a and big F of b. Okay. Another example. What is the area of the graph under x squared from x equals 0 to x equals 3? In lesson 9.2, we evaluated various Riemann sums to approximate this area. With the left Riemann sum, we found 5, right Riemann sum, we found 14, midpoint Riemann sum is 8.75, trapezoidal Riemann sum 9.5. But now we are ready to find the exact answer, the exact area under the curve. That's just equal to the definite integral from 0 to 3 of x squared dx. That's gonna equal to, we write it this way. So the integral of x squared is 1/3 x cubed. I write this vertical line like this, from 0 to 3. That means we evaluate our antiderivative at 3 minus our antiderivative at 0. So that's going to equal 1/3 times 3 cubed minus 1/3 times 0 cubed. That's 1/3 times 27 minus 0, which is 9. Yeah. As we can see, the midpoint and the trapezoidal sums were pretty close to our answer of 9. Okay? That's the area. Example 2. f of x is equal to x cubed. Find the area under the curve from x equals 2 to x equals 4. Alright? So that area is equal to the definite integral from 2 to 4 of x cubed times dx. That's going to equal to 1/4 x to the 4th power evaluated at 4 minus the whole same term evaluated at 2. That's equal to 1/4 of 4 to the 4th power minus 1/4 of 2 to the 4th power. Okay. That's equal to 64 minus 4, which is equal to 60. So the area under the curve from 2 to 4 is 60. Okay, more examples. The integral from 1 to 5 of ln x. Sorry, we're not ready for this one yet. Sorry about that. This is the integral of 1 to 5 of 1 over x dx. All right. Well, the integral of 1 over x is ln x because the derivative of ln x is 1 over x. And we're doing this evaluated at 5 minus ln x evaluated at 1. So that's going to equal ln 5 minus ln 1. Okay. ln 1 is just 0. ln 5 is about 1.6. So this is approximately 1.6. Okay. Next, the integral of sine x dx from 0 to pi. Let's be careful. The integral of sine x is not cosine x because the derivative of cosine x is not sine x. Because the derivative of cosine x is negative sine x, the integral of sine x is negative cosine x. So this is negative cosine x evaluated at pi minus cosine x evaluated at 0. So that's going to equal to negative cosine pi minus negative cosine 0. Okay. Cosine of pi is negative 1, so negative of negative 1 is 1. Cosine of 0, cosine 0 is also 1, so we have another negative of a negative, so it's 1 plus 1, which is equal to 2. Okay. Last example, the integral from 1 to 3 of e to the x dx. Okay, the integral of e to the x is e to the x because the derivative of e to the x is e to the x. We want to evaluate it at 3 minus e to the x evaluated at 1. So that's going to be e to the third power minus e to the first power. Okay. So e to the third power minus e is going to be about 17.4. So this is about 17.4. All right, that's it.